Assalamualaikum and very good morning. Let us go through together the manual of robotics in action, robotics laboratory design and verification using Coppeliasim. So this manual or document acts as a guide for you to go through the lab on your own. Inside there's a section introducing you to the field of robot design and testing. A field of robotics. And then we will look a little bit on the robot design steps. And after that, it brings you to the type of test we have in the robotics laboratory. Some precaution on when using simulation in robotics lab. And then a tutorial on using Coppeliasim with Cara Robot. And some additional info is tips on using generative AI like ChatGPT to help with your programming tasks. So let us go through a brief introduction to the robotics laboratory. Robotics is the engineering discipline dealing with the design, construction, and operation of robots. In engineering study, the focus of robotics field is on the design of robots to meet the desired requirements. When you design a robot, we need to test whether it meets the requirement or specification. Robotics lab is essential as it provides a controlled environment to test, analyze, and validate designs before deployment. Common verification tests in robot design is presented in the following sections. So we have kinematic testing, dynamic, sensor calibration, and accuracy, control system validation, payload and endurance testing, environmental testing, safety verification, software in the loop, and hardware in the loop testing. So for today, we are going to look at the first type of test, kinematic testing, that is to validate or verify the movement capabilities of each joint and the accuracy of end effector positioning. And we like to ensure that the robot's range of motion and the speed align with the design specification. In the real practice, this includes, among others, identifying and testing the singularity points. So at the very least, through the lab exercise, we will do the first part of the kinematic testing. Now let's take a look at the third part of the manual, tutorial on using Coppeliasim simulation platform. So first, the installation and test settings. And after you have installed and set it, so in our lab, we go through the Python installation, and then we will use Python as well as the embedded script of preferred choice. And after that, the manual go through the steps to set up your first robot. So it talks about adding and arranging objects, and after you have add objects like links and joints, the manual shows some tips on programming, how to call the address of the object for us to then programmatically do something on the object, and a little bit on user interface. For when you have to allow user to input easily information like joint angle and so on. And there's some tips on using generative AI. So this will speed up the programming effort. Just a little bit of precaution, there are some changes recently where Coppeliasim has introduced new API syntax. API means application programming interface. Some syntax, some code to help us with controlling the joints and what do you call, and whatever interaction with the robot and components in the software. So some of the changes include in the old one, for example, use a more elaborative syntax like sim.getObjectHandle, but now we are left with just sim.getObject. So whenever you use generative AI to ask for suggestion on how to program in Coppeliasim, you might get from now and then answer that use old syntax. So just be aware of this, and whenever thing does not go in your way in the Coppeliasim program, it might be because of you are using the old syntax. So I recommend when this happens, you can there's always what do you call in the debugging mode of Coppeliasim, it advises you to look at the syntax, so then you can change one by one. Okay, so that's all. Thank you very much for listening to the introduction.